Okay, Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. And a very good morning to all. This is our lecture, Learning Unit 1. Kenapa dia bergerak sendiri? Kejap ya. Lama. Kejap. Okay, STK1863, Analytical Chemistry. Okay, kita dah cakap pasal course assessment tadi kan. Ada quiz, assignment, midterm and final exam. And this is the Learning Unit 1, the Analytical Chemistry Overview. Okay. And this is what you need to achieve at the end of the learning unit, where you need to be able to define what is analytical chemistry. Tadi saya tengok analytical chemistry awak dah ada define, but then nanti kita tengok lagi the definition from book macam mana, and explain the scope and application of chemical analysis. You need to know what is the scope and the application of chemical analysis. Okay, sometimes we ask you on what is the application of chemical analysis. So, kena tahulah apa application dia. The second one, to distinguish and explain the quantitative analysis and qualitative analysis. You have to know what is the difference between the quantitative, what is the between the quantitative analysis and the qualitative analysis. You have to know how to differentiate. You need to know how to explain, and also you need to know about the examples of each of the analysis. The third one is on the explanation on the steps involved in chemical analysis. You have to know there is 9 steps involved in the chemical analysis, and you need to explain each and every steps. The fourth one, understand the common analytical problem. Okay, yang biasanya kita jumpa apa contoh-contoh analytical problem. Explain the quality assurance and quality control in analytical chemistry. The fifth one, use different units of concentration. And the last one is to calculate the basic statistic measurement. Okay, for this first class, saya akan we will cover only on the 1, 2, 3 saja dulu. 1, 2, 3, 4 saja dulu. Nanti QA/QC, lepas tu calculation of concentrations, lepas tu statistic measurement kita akan cover for next class. Boleh? Okay, now we give you the analytical chemistry overview on what is analytical chemistry is according to the Valkakel et al. Okay, they define the analytical chemistry is a metrological science. Okay, that develops, optimizes, and applies measuring processes intended to derive the quality chemical information of both global and partial type in order to solve the measuring problems posed. Maksudnya kita the analytical chemistry ni salah satu cabang metrological science. Metrological science ni satu yang berkaitan dengan kita kena tahu kuantiti bahan, okay, quality bahan. That is what we call as metrological science. We give in term of measurement. Kita measure dia. Kita tak cakap dia sahaja sebagai okay, air ni dia ada lead. For example, the drinking water contain lead. So what is the concentration? So there come the analytical chemistry. Okay, itu yang kita katakan sebagai analytical chemistry. Kita bagi in term of number, concentration, okay, mass, macam tu. So analytical chemistry, a metrological science that develops, optimizes, and applies the measuring process. They involve measure. Okay, so that we can say that the chemical, contohnya air, in term of water quality, in term of, for example, kita ada air sungai. Dia cakap sungai ni bersih ke tercemar? Is it a polluted river? Is it a clean river? So that's come the analytical chemistry part to quantify and to qualify the water. Contohnya air sungai tadilah, air laut ke apa ke, kita tengok tahap kecemaran, kita kena tengok in term of the quality and the quantity of chemicals in the river or in the sea. Okay, so itulah kita cakap pasal analytical chemistry. Next, okay, the definition implies the analytical chemistry as the science of measurement. Kita cakap analytical chemistry is the science of measurement, berkaitan dengan ukur-ukur benda ni. It's not only implies on the quality of the chemicals, but also it involves the quantity. It poses dual character, develops and applies. Kita pun, we need to develop also the tools and also apply the tools. Okay, dia melibatkan fundamental knowledge and also the practical knowledge. Sebab tu, in this course, analytical chemistry, we need to also embed the laboratory practical. So dia awak ada idea, bukan saja in basic idea but also in the practical area. The third part is it delivers information about the material or system studied. Okay, apa awak boleh dapat daripada bahan? You are given a chemical or substance, for example. You need to know what is the information about the material, about the substance, in terms of the color, in terms of the mass, in terms of the constituents in the material. Itu contoh-contoh lah in analytical chemistry. And the fifth one, it regards a measuring process that can be called as analytical process as the vehicles for obtaining the information. Dia juga melibatkan yang macam saya cakap tadi lah, is involve the measuring process. Kena ada ukur bahan tu, the concentration, the mass dia kan, and also the volume, so that it gives us the idea on what is the information that we can get from the material. Contohnya dibagi bahan tertentu, you are given a sample, contohnya sampel tanah, tiba-tiba je kan kita bagi sampel tanah, for example. So, what you need to know about the soil? Of course, you have to measure first the soil. Maybe you want to determine the mass of water in the soil. So, of course, kena tahu the mass of the soil before drying and after drying. Then you minus the mass before and after drying. Then that is the mass of water. Tu je lah simple punya analysis kan. And if you are given the task to determine what is the constituents in the soil. So, awak kena guna tool lain pula lah. Tak boleh nak tengok-tengok je kan. Tengok-tengok je boleh tahu apa ada dalam tanah. Usually we need to know, we need to determine by using instruments lah. For example, kita ada guna AAS ke, but if you need to use AAS, you need to extract first the chemicals. Tak boleh tiba-tiba letak tanah dalam AAS. AAS ni adalah atomic absorption spectroscopy techniques where you have to dilute or what we can say is provide a solution so that the solution can be put in an AAS instrument. Then the AAS will read the concentration of lead. Dia boleh tahu. Ini contohnya kalau we use this lamp, UV lamp dia, kita guna nickel. Then if there's any nickel in the soil, dia akan bagi awak maklumat berapa concentration nickel tu ada. So that is another part lah, nanti tinggi sikit lah. Pada coming semester, maybe the second or third semester, awak akan belajar pasal instrumentation pula. Nanti final year pula awak belajar pasal benda yang awak kena analyse sendirilah. Okay, next. These are the scopes and application of chemical analysis. Okay, boleh nampak kan banyak cabang chemical analysis ni cover. They will cover you on chemistry, of course lah. Chemistry, which includes biochemistry, inorganic chemistry, organic chemistry, physical chemistry, semua melibatkan chemical analysis. And if you look at the physics part, yang berkaitan dengan astrophysics, biophysics pun kena tahu on chemical analysis. In term of engineering, bukan saja chemical engineering, but the civil, electrical, mechanical pun, you need to know how to analyse a chemical. Semua benda ni melibatkan all of these scopes of study, they will need the skills of chemical analysis. So, penting sangat awak belajar on chemical analysis. Medicine, for example, the clinical chemistry, medicinal chemistry, pharmacy, toxicology, pharmacognosy, semua pun kena tahu chemical analysis. Okay, kena tahu macam mana nak buat dilution, solution, sebagainya. In material science, polymer, solid state, semua tu. In social science, in anthropology, archaeology, agriculture lagi lah. You have to know in term of bahaja, contohnya kan, the fertilizer. Dia kena ada ratio of fertilizer and NPK, which is nitrogen, phosphorus and potassium kan. Dia punya percentage kena betul. That is chemical analysis. In agriculture, you need to know animal science, crop science, food science, soil science, horticulture, semua melibatkan the idea of chemical analysis. Environmental science, yang saya sebut tadi pasal air, water quality dan sebagainya, geology, pasal geochemistry, batu, tanah semua tu, biology, botani, genetics, microbes, zoology pun semua nak guna idea of chemical analysis. So what we can say is analytical chemistry entangled in almost every branch of our lives, from solving crimes. Siapa dah tengok dulu zaman saya tu suka tengok CSI. Zaman korang yang Korean movie ni, banyak juga saya tengok cerita pasal solving crimes kan. So you need to know lah idea of chemistry juga. Pasal analyse darah yang lama tu, kena tahu apa kan beza dia, the iron inside kan. Kalau dah nampak sangat dia punya oxidation tu, lamalah darah tu. Kalau dia masih fresh, the colour would be different. Okay, macam tu kan. So that's the fun part of the chemical analysis lah. Banyak benda kita boleh discover. Pasal siapa yang minat pasal forensik dan sebagainya kan. And it involved from solving crimes to weeding out harmful chemicals used in consumer products or helping break new ground in the medical field. Semua melibatkan the knowledge of chemical analysis. Penting sangat kena belajar ni. So, you have to know, macam yang saya cakap tadi, kita ada dua kategori utama. There is two types of chemical analysis, which are the qualitative analysis and quantitative analysis. Okay, kalau sebut qualitative, we need to identify saja. Kita tak ada quantify. Kita identify je benda. What. Kalau soalan what are found in your drinking water. Contohnya, you have a bottle of drinking water. So have you ever think that whether your drinking water is safe to be consumed? Pernah tak awak terfikir, beli-beli je kan air ataupun ambil-ambil je air daripada mana-mana sumber. Kita minum je tak apa, tak ada masalah. But then you have to think whether your drinking water is really safe for you or not. Okay? So for example, biasanya dalam drinking water, kita risau saja dia ada heavy metal. Heavy metal for example lead ataupun nickel. Kan, benda-benda heavy metal ni, if you consume them, in the high concentration, that it will give you they will give you the effects in terms of health, serious health issues. For example, kalau terminum air yang ada kandungan lead ni, sebenarnya you can get it from the pipeline system tu. The pipeline system yang dulu-dulu lah, sekarang ni kurang sikit, tapi masih ada kot yang ada kawasan guna pipeline yang besi. So yang rust tu boleh jadi iron, ada leaking of lead. So kena hati-hatilah kalau minum. Saya tak cakap lah semua air minuman ada macam tu. Usually kalau yang dah proses dia okay lah. They will give you the yang baik lah, yang dah dirawat. But then kalau takut-takut sahaja yang kita ambil daripada yang very kawasan-kawasan air, tadahan air yang kita tak dirawat lagi, tu bahaya sikit lah. Okay. So that is qualitative. If we ask about identifying the chemicals present in the sample in terms of just to identify what is the chemicals. Kalau kita cakap pasal quantitative, we will next do what and how much. Okay, dia ada value dia ada concentration dia. Okay, so the qualitative involves the identifying, quantitative, separating, identifying and quantifying. Biasanya kualitatif tu kita tak libatkan sangat separating, but in quantitative kita kena ada separating dulu, so that all the disturbances, macam benda-benda yang mengacau kita nak buat quantitative tu, akan kita omit dululah. We need to remove all the disturbances tu. Okay, so that we can find the concentration. For example, kalau drinking water, maybe dia ada 0.05 mg over liter of iron. Ada zinc, berapa concentration zinc? 0.01 ppm contohnya kan, macam tu. The common example of qualitative analysis to identify the products. So, ini example dia, awak kena tahu jugalah idea. But it is not limited to this example only. Awak pun boleh bagi contoh-contoh yang lain asalkan betul. For example, qualitative analysis. Kita ada identify the products of a chemical reaction. Okay, chemical reaction contohnya. Ataupun we screen athletes' urine for the presence of performance enhancing drug. Okay, kita nak detect ada tak dia ambil drug. Jadi ada urine test for athletes lah biasanya. Or determine the spatial distribution of PB on the surface of airborne particulate. Kita nak tengok dia punya distribution saja. Kita tak tengok concentration dululah. Okay. Next, contohnya kita nak tengok chemical test banyak lah. For example, sekarang ni pun banyak test-test yang terlibatkan COVID-19 test. Itu pun involve chemical analysis. Yang RTK-PCR tu kan, RTK antigen, semua chemical analysis. Currently, most qualitative analysis in term of instrument, kita boleh bagi contoh, for example, infrared spectroscopy, where you can determine in chemicals or in a substance, you know whether there have a functional group apa yang ada. For example, kalau kita extract anything from leaves, apa benda lah, daun-daun apa kita extract. We want to know what kind of or what is the functional groups in the leaf extracts. So, kita boleh tengok guna IR. The IR will give you information, ada tak C double bond O, ada tak OH group, ada tak C double bond N group, ataupun ada tak C double bond C group. Dia terbagi tahu tu je, tapi dia tak akan quantify for you berapa banyak kita ada. And for example, nuclear magnetic resonance spectroscopy, okay, NMR. NMR will give you also in term of structural lah. Maksudnya dia bagi awak H2 hydrogen compound tu, hydrogen compound pula. Hydrogen ada dekat hydrogen pada carbon yang mana, for example. Itu lebih mendalam lah. This will be learned in instrumentation or chemical instrumentation. Okay, subject instrument nanti kita panggil. So for the quantitative analysis, we need to know the elemental analysis of a new list. For example, kita tahu we have synthesized a new compound. So you need to know the elemental analysis. Berapa persen carbon, berapa persen nitrogen, berapa persen oxygen in a newly synthesized compound. So that is what we call as quantitative. So the numbers, that is quantitative. And you need to measure the concentration of glucose in blood. Ini orang selalu apa panggil penyakit tu tadi, Astagfirullahaladzim, kencing manis kan. Okay, kencing manis dia nak tahu glucose in blood. So kena tahu concentration glucose, tinggi rendah macam tu kan. Or determine the difference between the bulk and surface concentration of Cr in steel. Okay, dalam steel kan kita campurkan krom juga kan, chromium kan. So kita tahu kalau bulk dia macam mana, surface concentration dia mana. So that is the quantitative analysis. Any problem setakat ni? Laju sangat ke saya cakap? Boleh?
Tak.
Tak?
Okey.
Boleh.
Okey, madam.
Okay, very good. Ada soalan setakat ni? Kalau tak ada, kita teruskan.
Madam, sorry madam.
Ya. Who's that?
Tadi ada satu student tanya sini, Madam, are we supposed to write notes from your lecture slide ataupun kami orang boleh salin dia later or buat sendiri or whatever?
The lecture notes will be given to you, but it's up to you lah. Kadang-kadang kita waktu orang cakap kita tulis dia lebih faham. Itu untuk tujuan sendirilah. But then the lecture notes will be given to you. Clear?
Right. Thank you, madam.
Okay, welcome. Tak perasan saya ada soalan ni, tak apa. So, thank you. Siapa tadi? Karen, betul ke saya?
Yeah.
Okay, thank you. So, next, we move to the quantitative analysis. Quantitative, dia ada lagi beberapa pecahan. There are few types of quantitative analysis. This will be learned specifically nanti, especially the gravimetric analysis, where it involve in measuring weight. Biasanya kalau kita nak tahu weight of a, contoh a solid water sample. Okay. Okay, contohnya to measure a suspended solid in a water sample. You are given a water sample from Sungai Sarawak, for example. Sungai Sarawak Kuching tu kan, depan waterfront tu, berapa jalan, sekarang dah boleh jalan-jalan kan. So, awak kena pula dah bagi water sample. So, as a chemist, you need to determine what is the suspended solid in this river water, dia cakap. So, awak kena tahulah how to measure. Nanti kita akan belajar the 9 steps to measure. The 9 steps to start a chemical analysis. Nantilah. So, basically, that is what we call as gravimetric analysis when you need to find the suspended solid. So, awak nanti kena balik ke lab kan, buat filtration. Lepas tu, filtration keringkan dah. Before the filtration, awak kena timbang dulu filter paper tu. Nak tahu, tolakkan nanti dengan the total suspended solid dia tadi. So, that is what we call as gravimetric, where it involves the measuring of weight, mass of the sample ataupun mass of the solid. Okay, kalau gravimetric, it involves mass. Volumetric, instead, it involves the volume. Okay. For example, you need to determine the acidity of a sample of vegetable oil by measuring the amount of base that is need to neutralize a sample of vegetable oil. Jadi, kalau nak tahu the acidity, we need to determine by using the neutralization method, where kalau kita ada amount of base yang kita gunakan to neutralize the acid, then you can get the the volume of acid yang sebenarnya lah. So that is what we call as volumetric analysis. Whereas the electroanalytical method, it measured in term of potential or current. Dia melibatkan current dia cakap sawak current macam tu kan. So electroanalytical involve electrons, electrochemical cells. For example, in an electrochemical cell, 2 copper electrons are submerged into copper to sulfate solution. Dia ada 0.05 molar and 2 molar. So connect through a salt bridge. So dia nak tengok current dia, berapa dia punya potential or current. So that is what we call as electroanalytical method. So daripada concentration tu kita boleh tengok perbezaan current dia. And if we talk about chromatography, it's type of a quantitative analysis as well, where it involves a separation of material, where the material interact with 2 different phase. For example, contohnya separation of 3 compounds on a TLC plate. Awak nak tahu dalam satu bahan tu dia ada berapa compound. Okay, contohlah you are given a chemicals or a constituents or a sample extract. Awak dah extract, dia bagi contohnya dia extractkan daun sirih lah contohlah. So the extract dia nampak macam paste warna hijau because of the chlorophyll, semua dia kena ambil lah. But then you have to undergo the chromatography process untuk separation. Then also from the separation, it gives you the idea on how many pure compounds in the sample tu. Tapi tak boleh guna direct the sample yang kita extract tu, tak boleh terus lah. We need to separate dulu, buang-buang benda-benda lain dulu. Dah towards the end, usually yang mungkin ada dalam tu ada 3 compound, they will give you the idea dalam TLC plate. Kita panggil TLC plate ni macam satu keping kertas. Rasanya awak ada buat tak? Pernah buat eksperimen during your study? I mean during the STP ke ataupun matriculation, ada tak buat guna TLC?
Ada, madam.
Ada.
Letih je saya kat panjang-panjang kan. Rupanya ada pengalaman. So that is what we call as that is the chromatography technique, what we call yang kita katakan is a separation method lah. Okay, dia dibahagikan. Letak colour-colour, nampak kan dia have different colours kan. Kalau ada dye lain-lain colour dia, and they will give you different retention time as well. Awak akan calculate dia punya retention time berbeza. Okay, kalau retention time sama, the compound is same. Kalau retention lainlah compound tu. That is chromatography. Dia boleh jadi dua lah, qualitative and also quantitative. Tapi kalau kita cakap berapa banyak compound dalam sampel ini, that is quantitative lah. Okay, next spectroscopy. Kita ada ini quantitative analysis. Actually, kalau NMR is actually a qualitative analysis. Kalau kita cakap quantitative analysis, ni kena betulkan sikit nanti It's not totally quantitative kalau NMR ni. Silap pula saya tengok kat sini. So, the spectroscopy kalau melibatkan quantitative, they will give you direct amount of the sample. Kalau NMR, they didn't give you the amount of concentration. Dia hanya bagi awak the idea ada ke tak ada benda tu. Okay? Ada tak carbon dalam ni? Ada tak C attach dengan kumpulan apa contohnya? Ada tak OH kat sini? Yang attach dekat carbon yang mana? That is the idea of NMR. Kalau for example yang kita boleh tahu concentration yang saya sebut tadi AAS, ataupun another one is carbon, hydrogen, nitrogen analyzer. That will give you the idea on the percentage of chemicals inside of the compound yang diberi lah. For example, dibagi satu benda, then you analyze using CHN, the instrument will give you the percentage. For example, carbon berapa peratus? 50%. Nitrogen 30%. The other 20% maybe hydrogen macam tu. Okay, that is in term of quantitative. Sekejap ya. Next, this is a different methods provide a range of precision, sensitivity, selectivity, and speed. Okay, ini kalau kita tengok, each and every method will give you a different precision, sensitivity, selectivity, and speed capabilities. Kalau if you look at the gravimetry, the speed is low, the selectivity is not very good, but it's a poor moderate. Kalau kita cakap selectivity, macam mana dia select sesuatu benda tu macam specifically kepada satu bahan tu. It's a kind of poor and moderate lah. But then kalau ada chromatography, very relative, if you look at the chromatography, it's a good selectivity. It's selective. It's not all chemical can undergo the chromatography process. However, in term of trigonometric process, yang ni kita selalu buat kalau kita nak determine in term of acid base. Trigonometry is a kind of poor moderate as well. Precision is about 0.1 to 1 and the cost is tak tinggi sangat lah. And speed also moderate. Potentiometry ni berkaitan dengan elektron juga. Just macam electrogravimetry juga. Is a potential. Punya difference kita nak tengok. Precision dia lebih tinggi. Approx precision. Okay. Next spektro, kita tengok sikit-sikit je lah. Ini is not really important for you tahu satu-satu, tak ada just bagi awak idea contoh-contoh different methods that will give you different precision, sensitivity and selectivity. Awak kena tahu. That's why you need to have the idea before you do any analysis. You need to determine whether it's a gravimetric analysis ataupun contohnya kita nak guna apa bahan, what is method that we need to use, what is the approach, the suitable approach. So, kena tahulah, lepas pilih tu, you have to think about the laju ke. The experiment would be take 2 days ke, 1 day only, 1 hour ke. You have to know in term of speed. Cost juga, of course, kalau kita guna benda yang laju, dia akan ada lagi mahal lah dia punya. If it is fast, it would be moderate to high cost. Macam tu lah. But then it's okay. This is not really important for you to know. But then, you need to identify lah. Maksudnya awak kena tahulah yang mana method yang sesuai digunakan untuk analisis at different situation. And next, these are the steps involved in a typical quantitative analysis. Ini yang saya kata penting for you to understand and for you to remember, to digest, to ingatlah sampai bila-bila. Okay, because sebenarnya benda ni awak dah tahu pun, but then it put in a 9 step macam ni lah. But I believe that you have the experience on this because biasanya budak-budak sains ni daripada darjah 1 pun dah tahu dah. You need to know what is your problem, what is the method to do, how do you do the sampling, how to prepare the sample in the laboratory scale, how to do the replication, okay. And to prepare the solution macam mana, to eliminate the interferences sebab kadang-kadang ada benda kita tak nak tahu pun dia sibuk-sibuk juga kat situ, kena remove. And how to measure the property and do the calibration, and lastly to analyze the data. I believe that all of you have know already all these 9 steps, but then in this lecture we put it in a very we put it for you in terms of numbering so that you can understand and you can remember it very well. Okay, ni sebenarnya yang benda penting dalam lecture unit ni lah. Okay, so we move to look at the first part, which is the defining the problem. Okay, if you are given a problem or you are given a sample for you to analyze, or dibagilah sampel, so apa awak kena tahu sebenarnya. So dibagi, biasanya awak akan tiba-tiba lah tanya, aku nak buat apa ni? So that is the defining the problem. The first part yang awak buat tu, nak buat apa ni? Selalu kan, kita bagi benda pun, nak buat apa Walah apa tu that is the defining problems. Actually, the first part of the defining problem. Okay, you need to know the factors, which is the first one. What is the problem? What need to be found? Lepas tu dibagi kan, dah bagi contohnya tiba-tiba kena bagi satu sampel entah apa-apa. Sampel apa ni? So that is one of the defining problem. There come the idea, sampel apa ni? What is this sample? So the question is, what is the color? What is the weight? What is the smell? For example, that is first part lah. awak kena lalu kan. Macam dulu-dulu, kalau saya tengok anak saya PDPR kan, dia punya science subject, darjah 1 ni, you're given the experiment simple je. Dia suruh hidu satu benda ni tutup mata. Contohnya kek kita bagi kan. Dia kena tahu rasa dia macam mana soft or hard. Lepas tu bila merasa guna lidah, dia kena tahu the test if it is sweet ke, masam, sour ke. That is how the step to do the analysis. Okay, kalau kita yang tahap bachelor degree ni, dia up sikit lah problem dia. Tak ada, dia nak bagi awak kek kan. Sedap sangat tu. Semua orang nak Okay, so they will give you some. Nanti dia bagi stool kan, tahu stool. Stool apa ke kan, manusia punya tak tahulah, haiwan ke apa. So you have to know what is the information that we can get from the given sample. So, dalam ni contohnya awak boleh fikirkan what needs to be found. Apa yang aku nak tahu ni? And what will the information be used for? Who will use it? Okay, for example, kalau sesuatu benda, contohnya daripada Kementerian Kesihatan Malaysia, they give you a sputum. Contohnya sputum Sputum ni kahak. Okay, for example lah. Kahak. So, kita tanya lah. Kahak kalau orang lain, maybe tak guna sangat lah. But for KKM, they will need what kind of information? Whether the kahak tu ada kandungan. Contohnya, satu cerita COVID-19 benda lain lah. But then ini cerita lain pula. Saya bagi information. For example, the kahak, you need to determine whether it's content of darah. Maybe darah tak nampak. But then you need to determine using chemical analysis. So, kena ada guna alat ataupun any chemical punya, kita panggil apa, solution that will give change colour. Kalau suatu benda tu, dia attach dengan darah ada. Ni saya tanya dululah. Senang cerita. Darah ada apa? Siapa nak jawab ni? Darah ada apa?
Red blood cell, white blood cell.
Yes, this is two biology.
Hemoglobin.
Yeah, we're talking about chemistry.
Iron.
Iron,
Iron.
potassium,
Exactly. Okay.
hemoglobin,
Hemoglobin.
zinc.
Betul. Semua tu. Ya, betul-betul.
Oksigen.
Oksigen. Dia angkut oksigen lah. Ada hemoglobin lah kan. But then basically the important constituents in chemistry, kita kena tahu ada ferrum lah kan. Ada iron kan. So, kalau macam tu, you're giving the information, you're giving something that you need to find the information on that. Kalau kita tahu itu kahak, kalau nak tahu ada darah ke tidak, tapi tak nampak colour darah merah. So, you need to find some of the chemicals that can attach with the ferrum or the iron, bahasa English the iron. Okay, that can attach the iron, then it change colour. Pada asalnya maybe the colour from colourless, kita ada air yang colourless, tapi kalau ada darah kita masuk dalam sputum tu, colour dia change from colourless to red, for example. So, that indicate the existence of apa kita panggil tadi, darah. Fresh blood ke, tak fresh ke, tak tahulah. But then that is one of the example that the second question infer you. What will the information be used for? Nanti KKM nak guna ni untuk menentukan whether ada penyakit apa ke. Kalau ada sputum dia ada darah, means indicate ada berlaku apa, luka di dalam ke, macam mana kan. So who will use it? You need to know lah. Siapa yang bagi sputum ni? Untuk analisis apa sebenarnya? Kalau KKM, mestilah berkaitan dengan kesihatan. Kalau benda lain, contohnya daripada kementerian, for example, saya bagi contoh je ni. Saya suka nak bagi contoh-contoh so that you can understand lah. For example, it come from the Kementerian Pertanian. Contohnya kan daripada Jabatan Pertanian. Dia bagi sputum. Maybe dia tak adalah kaitan dengan kesihatan. But then maybe it can say that from the sputum, it will increase the soil punya, orang cakap kesuburan tanah. So siapa yang nak rasa buang-buang sputum boleh meludahkan ke pokok-pokok supaya pokok-pokok semua boleh hidup subur. For example, macam tu. So, kena tahulah the information nak guna apa. So, who will use it is also give you the idea on what kind of problem that you need to define. Get it? Boleh faham? Tiba-tiba kan?
Faham.
Kenapa ada who will use it? Penting sangat. Who will use it? Yes, it's very important. Siapa yang nak tahu masalah ni? Contohnya kalau ada kencing tadi, kalau Jabatan Pertanian minta awak analyse, maybe it will give you the idea on the kegunaan dia as a fertilizer. But then if the Jabatan Jabatan Anti Dadah Kebangsaan AADK bagi awak air kencing, so of course dia akan nak tahu ada dadah ke dalam air kencing tu. So that is the importance of the idea on who will use the information. Boleh? Faham? Get it?
Faham.
Oh,
Yes, madam.
okay. So next, who will be needed? Who will it be needed? Lebih kurang juga, who will use it? Who will it be needed? Okay. How accurate and precise does it have to be? Okay. Kadang-kadang soalan, kadang-kadang the problem just need for you to identify saja, but you don't need to cakap apa? Quantify. So tak payah susah-susah sikit nak kita timbang-timbang ke apa. We just need to know whether ada benda tu ke tidak. The chemical exists or not. Okay. So kena tahulah how accurate and precise does it have to be. Perlu sangat accurate ke? Contohnya kalau in term of dadah concentration, kalau sikit maybe dia punya charges beza kot. Contohlah kesalahan penyalahgunaan dadah kan. Dia concentration dalam air kencing dia sikit. So just tak perlu accuracy dalam analysis ke perlu? It's very important for you to determine the drug concentration in a urine accurately and precisely. Sebab dia melibatkan apa? Melibatkan undang-undang. That's why you need to really accurate and precise with the result. Tapi kalau melibatkan air kencing yang hanya nak guna untuk kita nak tahu dia punya elemen saja, berapa nitrogen persen dia tak perlulah tak perlulah 99.99% value sangat tepat, tak perlu. Just kita nak tahu ada tak nitrogen dalam ni. So it will need you not an accurate and precise method lah. Guna method yang murah-murah je, yang boleh detect simple je, okay. But then tadi yang saya cakap kalau digunakan untuk undang-undang polis nak apa-apa, we need to very accurate and precise. Kita tahu persen dia betul-betul 99.99% tepat macam tu. And also in term of budget kan, saya cakap tadi, kalau kita nak sesuatu yang tepat, cepat, of course the budget is high. So kena tengoklah the project, budget dia ciput ke kan. Tengoklah macam mana. So you need to really determine the budget the method according to the budget. And the analyst should consult the client to plan a useful and efficient analysis, including how to obtain a useful sample. Okay, as an analytical chemist or analyst, awak kena tahu your client punya masalah apa, dia nak apa hasilnya, and how you can manage the budget, and how you can efficiently analyze using, and how to obtain a useful sample. Kadang-kadang kita semangat je tapi at last sampel yang kita dapat tu doesn't indicate what the client want. Okay, kita dah salah guna analysis maybe. Jadi client pun tak puas hati. So you need to discuss lah and consult the client. Ini dah dapat part nanti dah keluar bekerjaan lah. But then this is your role as a chemist. Kena banyak tahu. First part sekali kalau kita dibagi satu benda nak kena analyse, kena tahulah apa benda ni, apa kena tahu. That is defining the problem. Okay, next. The second one is the method selection. Okay, you need to know the factors. For example, the sample type, apa jenis sample. Is it solid sample, a liquid sample? Okay, the size of sample, sama ada kita perlu banyak ke, kita perlu sikit ke menentukan analisis tertentu. For example, in a natural product chemistry, you need to use, for example, kalau ada cakap, okay, daun apa saya nak cakap contoh. Bagi saya contoh daun apa kita boleh analyse yang seronok-seronok sikit. Seronok-seronok. Ada contoh bagi-bagi? Apalah sebut je.
Bifrem.
Pipram.
Bifrem.
Apa tu? Saya pula tak tahu Dakshiani. Tu nama awak?
Ya.
Apa tu? Bifrem?
Bifrem leaf. Yang dia akan tumbuh dekat leaf sendiri.
Apa sebenarnya? Benda macam memang dekat
Daun setawai.
Tahu nama bahasa Melayu tapi bahasa English. I think I did this when I was dekat sekolah menengah lah, like form 1.
Okay. Dia macam daripada daun dia boleh tumbuh daun lagi macam tu kan?
Ya.
Saya rasa setawa tu. Saya selalu dulu letak dalam buku.
Buku, ya. Letak dalam buku.
Nama dia apa? Sekali lagi?
Via firm.
Via firm. Oi, okay. Okay. For example, that ada lift lah setawai. Okay. So, kalau in term of medicinal pula. Kalau natural product chemistry, you need to determine, boleh berguna ke daun setawar ni nak mengubat penyakit. Contohnya, cancer, anti-cancer for example. Okay. So, kalau kita nak analyze daun tu sahaja, you need at least 1 kilo of the dry sample. Okay, to get the extracts and to do the separation, and at last you can get the compounds, then you can test it. Test guna test guna something kit yang ada cancer cell, kita boleh tengok mematikan cancer cell tidak. Tapi yang 1 kilo saya cakap tadi baru tak tahulah towards the end tu boleh capai tak. Sebab at last dia akan remove first maybe they remove some part of the leaves tu yang ada cover dia punya cuticle lah benda tu kan, yang lemak-lemak tu pun dah berapa banyak dah. Towards the end kita hanya dapat maybe 0.01 milligram or 0.01 gram ke yang betul-betul benda yang kita nak cari. That's why you need to know apa jenis analisis yang orang tu nak. Kalau setakat dia nak tahu what is the content of benda yang biasa, contohnya dalam daun kita ada apa yang panggil selulose, for example, selulose ni kalau satu daun pun dah nampak banyak kan. So maybe we can use only for about 10 gram je. Tapi kalau dia cakap I want to determine what is the compounds or the secondary metabolites in the daun setawar. So you have to come for terus sepatutnya as a chemist you terus fikir, aku ni at least kena ada 3-4 kilo ni, macam tu. Kalau cakap, saya nak tahu selulose berapa banyak dalam daun ni. Ni cukup 10 gram, 20 gram cukup, macam tu. So, you have to know the method used. The factors include the sample type, the size of sample, the sample preparation needed, apa jenis preparation you need to do. Whether it involve drying sahaja ke ataupun awak kena buat apalah sample preparation. Contohnya, lepas drying, nak kena hancurkan daun, you have to mill atau kita panggil blendkan dia kan, ground dia. That is the sample preparation process, and you need to know the concentration and range. Macam saya cakap tadi, sensitivity dia berapa banyak, kita nak tahu concentration dia, range dia berapa rasa-rasanya. Kalau melibatkan range, kalau kita rasa air, contoh kalau air dekat sungai, we expect that the concentration of lead would not be much lah. Kalau sungai Sarawak, tepi-tepi dia kita expect lah ada juga kilang, but then tak adalah kilang bateri ke kilang yang melibatkan heavy metal sangat. So we expect that the heavy metal would be not too high. So it's around 4 per billion concentration. Macam tu. Itu what need to do, what need to come in your mind. Kalau kita sebut pasal method selection. So kalau guna concentration rendah, AAS is good. Kalau tiba-tiba kita terfikir in a pond tu memang tempat pembuangan heavy metal, takkan boleh guna AAS. Sebab AAS hanya detect up to 4 per million concentration. Kalau dah melibatkan concentration tinggi, dah tak sesuai. That is why you need to think about the concentration and range. There come the sensitivity. Okay. And also the selectivity needed. Kadang-kadang for an instrument, dia terganggu dengan benda-benda interference. Interference ni sangat macam banyak For example, you have the soil sample tadi kan. Boleh jadi dalam soil sample tu kita sebenarnya nak detect maybe the concentration of chromium. Contohlah ada leaking of chromium dekat sama mana kan, dia punya mining site lah. So we need to only find the chromium, but then boleh jadi dalam tu ada lain-lain metal, earth metal yang lain lah. So you need to buang dulu the interference. Okay, so that is what we call a selectivity needed. It's very selective method. Kalau instrumen tu sangat selektif, dia tak nak benda lain. Kalau ada benda lain, dia terganggu, tak boleh baca dah. Error, cakap macam tu. So you need to remove the interferences. In term of accuracy and precision, macam tadi saya cakap, nak accurate berapa persen? Nak betul-betul accurate in term of concentration tu betul-betul ke? Ataupun just nak tahu persen besar dia? Maksudnya 50% is okay. Just tak perlulah 50.9876543%. That is very accurate. Kalau kita cakap 50%, is this accuracy dia rendah sikit lah. Tools and instruments available. And you have to know, kalau nak sesuaikan nak guna method apa, you need to also take into account the tools. yang available dekat lab juga. Kadang-kadang kita macam aim higher sangat, tinggi sangat kita punya angan-angan tu kan, tapi bila nak buat tak ada pula ada chemicals, tak ada pula ada instrument dekat lab ni, dah kena ulang balik, fikir balik nak pilih mana method yang sesuai. So you have to look lah kita punya kemudahan yang ada. The expertise, ada tak orang yang berpengalaman menghandlekan benda-benda ni. Selama ni tak ada orang buat, better you study betul-betul dululah. Better pilih tempat benda yang biasa dibuat so that there is expertise yang ada lah. And in term of cost, pilihlah cost yang kalau boleh tak terlampau tinggi. Speed of course, kalau boleh kita memang nak the analysis yang laju lah. Tak nak lah yang sampai bertahun baru dapat result satu macam tu kan. So does it need to be automated? Kalau boleh automated is very good kan. Kalau tak dapat, so mean awak kena pergi lab tengah-tengah malam ke kan. Okay, that is one of the example. Contohnya kalau GCMS, gas chromatography tadi kan, HPLC, high performance liquid chromatography, that is now dah semua automated lah. Awak ada 10 sampel boleh masuk terus, tak perlu tunggu dia habis. That is kind of automated lah. Contohnya kalau dekat lab yang melibatkan medical lab lah. Contohnya tadi yang cakap air kencing, urine punya, dia sekarang dah automated juga. Yang darah sampel pun automated. Tak perlu awak sentiasa ada kat sana. Mungkin awak boleh masuk dulu sampel dan awak boleh pergi lunch dulu. So this is one example lah. Are methods available in the chemical literature? Ni yang saya cakap tadi. Is safe if you can find the literature punya view dulu. Okay, literature review dia dulu. Baca dulu, ada tak orang buat this method. So that you can follow the method. This is what we call a standard method lah. Okay, ada available ke tidak? Better if you choose the method is available. If not available, you can still use the one that has been published doing the analysis almost the same with what you have. Contoh dia, the analysis guna daun sirih tadi kan. Awak guna tadi daun setawar. You can use that. But then you cannot aim that you can have the same result lah. Macam tu je lah. Okay. Ni baru 2 steps dalam chemical analysis Pertama tadi, awak kena tahu apa? Define the problem. Giving the sample, you need to define apa aku kena buat. That is defining the problem. The second one, to select the best method you can. So, method selection. The third one is obtaining the representative sample. Okay, which is the sampling process. Okay, kalau dikata you need to find awak punya pos lah, contoh ada kerja ataupun dekat ni nanti for your final year project, you need to find whether the Sungai Sarawak ada tak mengandungi COVID-19 virus, for example. So, awak kena pergilah duduk sana, ambil lah beberapa sampel. Tak bolehlah tiba-tiba duduk dekat satu tempat je. Okay, faham? It doesn't represent the whole sample of Sungai Sarawak. Awak kena tahu daripada hulu sampai ke hilir tu, awak kena tahu berapa point awak kena ambil air. Get it? Tak bolehlah tiba-tiba duduk relax kat waterfront, duduk kat situ ambil 10 botol air sungai. Lepas tu balik buat analyze. Then they said that, Sungai Sarawak tidak mempunyai COVID-19 virus. That doesn't representing the whole sample, or that does not representing the whole Sungai Sarawak punya mewakili Sungai Sarawak punya concentration of COVID-19 lah. So awak kena datang daripada hulu pergi ke hilir pergi ke hulu, saya tak pasti sebab ini kena tahu orang-orang yang tahu pasal sungai lah kan. Dari mana air mengalir kan, macam tu kan. So you have to know point mana. For example, the first point maybe dekat Batu Kawah. For example, dekat area Batu Kawah tu ambil sikit. Lepas tu second point maybe dekat kawasan Bako punya ke kan, sepanjang kawasan belakang kediaman Pehin Sri Taib tu kan, boleh ambil sikit air kat situ. That will give you the representative sample. And for your information, this is the most difficult step. Biasanya orang nak kena masuk dalam bot, lepas tu nak ambil air, kedalaman ketinggian air pun mewakili juga. Dia tak boleh lah ambil air on surface saja. Dia tahu yang dekat dengan sedimen sikit, tengah-tengah air. That is, you have to think, okay? Kita sebenarnya ambil sikit saja sampel tu, tapi you have to really ensure that it represent the whole sample tu. Okay? Macam saya cakap tadi pasal sungai, tu pasal sungai kan. Pasal tanah pula, tanah yang ada dekat bawah contohnya, masih ada lagi tak concentration of apa dulu mining kan, tin tu tin ke rasanya mining kat bawah tu. Masih ada lagi tak sisa-sisa dia dekat kita punya apa tanah contohnya. So you have to know how you can collect the sample so that it will represent the whole bulk sample tu. Okay. The third one is the sampling. Okay. The fourth one, lepas dapat sample, after you get the sample from site, okay, on-site sample, you need to get all the sample come back to the lab. Okay, dekat lab pula tak boleh dah siap dah, dia boleh analyse sendiri. No, you need to prepare the sample supaya sample tu boleh diguna untuk analisis so that it will be convert into a usable form for chemical analysis. For example, kena keringkan dulu. Contohnya air tadi tak payah keringkan, maybe you need to filter out all the suspended solid, tak nak kacau our analysis nanti kan. Itu pun information that you need to find. Awak guna tak suspended solid tu sebagai awak punya data nanti. Kalau tak guna, just omit. Macam tu. For example, kalau kita ambil tanah mud, for example, lumpur, nak kena dry dulu lumpur tu. Sample weighing, maksudnya kita kena timbang, mixing. Sama ada kita perlu kecilkan sample size tu. Kalau perlu kecilkan, we need to ground into acceptable particle size. Okay, mix with some chemicals and store it before the analysis. Kita takut sampel rosak, lama-lama simpan macam tu je. So, we need to do some chemical punya kita panggil dia preparation method so that dia tak rosak lah sebelum kita buat the real analysis nanti. Simpan dalam peti sejuk, nak tahu betul ke sampel ni kalau simpan peti sejuk berapa lama boleh tahan. That is the important part lah. And replication. Lepas dapat satu sampel tu, we need to do the replication. So that because this is to reduce the error lah then improve the quality of the result. Kadang-kadang satu analysis tu analyze, we have the sample ready. But then kadang-kadang tangan kita ni terlebih masukkan chemical lain. For example kan, indikator dia kita terletak banyak. So the result will be different for example. So kalau kita ada replicate, at least we have 3. What we call is triplicate, at least 3. So that kita boleh we can say that the result is reliable. Okay. So apa kata-kata sebagai replicate is a portion of materials or approximately the same size that are carried through an analytical procedure at the same time in the same way. Tiba-tiba replicate tu hari ni aku buat hari ni pertama, esok kedua. Tak boleh. Dia kena situation yang sama, suhu yang hampir sama, dekat tempat yang sama, cara pengendalian yang sama, dan orang yang mengendalikan pun sama. Tak boleh tiba-tiba you buat satu, I buat satu, dia buat satu. But then kat lab pun kita kena terpaksa buat macam tu kan. Kadang-kadang kan dekat laboratory punya practical. Maknanya kita assume je lah. In the real world, you need to do at the same time, at the same way. Okay. And kalau boleh, the same person. Sebab tangan orang ni lain-lain. Okay. That's why some of the instruments, kalau ada di mana-mana, kita biasa galakkan orang yang sama saja memegang instrumen itu. Sebab tangan dia lain. Tangan orang ni kadang lain. That is one of the reason lah. Okay. So, sekarang dia ke-5. Ke-6, preparing sample for analysis. Tadi kita baru nak sample tu saja. Baru nak ambil sample tu. Now we do for the analysis. Okay, you need to know the solvent chosen. Should dissolve the entire sample completely or without decomposing the analyte. Okay, kita kena tahu in term of solvent selection whether you want to dissolve all the sample or you want to dissolve some and some part of the sample would be removed. Macam tu kena tahulah. Kadang-kadang solvent tertentu is not suitable to be used for some kind of sample. Kena tahu. Okay, air tak semestinya melarutkan semua benda. You want the sample to be dissolved entirely. So, you need to find the suitable solvent. Okay, various types of solvent in dissolution method. There are few types for you to dissolve sample. For example, nitric acid, sulfuric acid and hydrochloric acid. And ada juga lagi yang lain selain ni. Lepas buat preparation tadi, yang kita nak pergi analisis ni, kita buat separation. Okay, separation ni, the objective is to eliminate the interferences. Okay, kita tak nak, contohnya if you have the sample, soil sample tadi, kadang-kadang ada batu-batu yang tak nak dissolve tu, kita tak nak kacau, so we need to eliminate them. Senang sajalah, tapislah, one of the most easiest way. Okay, interference are substances that are prevent direct measurement of the analyte and must be removed. And the interference can be removed via various suppression techniques, for example, filtration and crystallization. Okay, kalau satu lagi benda yang kita panggil impurities ni, for example, if you work in a field of synthesis, nanti kalau siapa buat FYP di bawah bidang inorganic chemistry synthesis, for example, organic chemistry synthesis, you mix A plus B chemicals there to get, you can get C, right? But then sometimes A plus B, you get C plus D. D is the impurities yang tercampur sekali, the mix together with the C. So you need to remove the interference, whether the filtration, kalau filtration senang. But then sometimes in a compound, they mix together dalam solid tu. Ada juga benda-benda lain yang terlekat sekali di dalam crystal, di dalam solid. So you need to do, what you need to do is what we call as crystallization tadi. Rasanya macam awak buat eksperimen yang copper sulfate yang colour biru tu. Colour biru tu awak larutkan dulu kan sampai super saturated, then awak biar dia crystallize. This is what we call is crystallization. It is actually a purification technique lah. Untuk kita dapat yang pure lagi. Lepas kita dissolve, kenapa lah nak dissolve, nak buat lagi. Dissolve, buat lagi. It's actually a step for you to do a purification process. Clear? Ada soalan setakat ni?
Clear.
Okay, kalau tak ada kita move to the step, which is the performing the measurement and calibration. Okay, biasalah lepas kita buat analysis dah ada sample dah cantik dah. We have triplicate sample dah, sample maksudnya yang ready to be analysed dah. Tak adalah sample yang kita tak treat lagi, the treated sample already. Okay, so kita nak perform the measurement. So the physical or chemical property proportional to the analyte concentration is measured. So kita kena tahu the physical dia dah nampak, the chemical property tu kena analyse guna chemical technique, chemical analysis technique. Suitable standards must be measured to determine the relationship between analyte quantity and the physical or chemical property being measured. This where come the calibration process. In any instruments, you need to compare your result with the standard. That is why the importance of standard. Jadi kalau, for example, you are using UV visible to determine the concentration, you need to do the calibration curve first. Maksudnya, calibration ni maksudnya awak sediakan satu graph yang mewakili standard kepada concentration itu. For example, in order to determine the nickel concentration in a sample, awak nak determine nickel punya metal. So, awak kena sebelum analyse sample, before you analyse your own sample, yang sample awak collect daripada air contohnya tadi yang dah di-treat, dah dibuat treatment, and you believe that all the interference has been removed. So, now you need to do a standard calibration curve. Nak buat standard calibration curve tu macam mana? For example here, you need to prepare 2 ppm, 4 ppm up to 10 ppm concentration. Ini dia guna 1, 2, 5, 7, 9 dan 10. Okay. Ikutlah. Dia at least you have at least 5 points. So that awak sediakan nickel concentration yang known. Awak tahu dah berapa. Awak sendiri yang buat. Bukan daripada sample tadi. Di nickel ni kita ambil daripada sebut nickel sulfate for example. So kita tahulah berapa gram nickel kita dah letak so that we can get the concentration 2. For example 2 ppm sampai 10 ppm. Then we put the sample yang kita dah sediakan yang concentration, non-concentration of nickel tadi ke dalam AAS. Then the AAS will give you the absorbance value. For example for 2 it will give you around 0.07 absorbance. So mark kat sini. Then dah dapat the calibration line ni cantik ni lurus. So cantik lah kita panggil lah dekat-dekat je. Kalau jauh-jauh it will be not good. So we have to repeat. The acceptable value of R here, R square is supposed to be 0.9999. If you get 0.98, okay lah juga. But then the best one is 0.999 dia punya calibration. Dia punya R value dia. R square value di sini. So after you get this one tadi, Now come with the benda yang awak tak tahu dah. Yang tadi ambil daripada air tadi. The one sample from water. Awak ambil. So you analyze. The absorbent given is 0. For example 0.2 kan kat sini. So the absorbent given here 0.2, absorbance given here. So the concentration is around maybe 6.5 kat sini lah. Ini 7 kan. So you can know that air kat tadi ada 6.5 ppm of nickel. So that is how the calibration curve works. Boleh? Faham? That is why you need to first do the calibration curve first, the standard calibration curve. Okay, inilah yang pentingnya calibration tadi. Example je lah. In order to establish this relationship, one or more standard solution is needed. Ini saya panggil tadi, sebenarnya tak adalah one. One ni tak boleh nak bagi awak apa-apa idea pun. Kalau awak buat satu je kat sini, nak tengok apa Nak tengok sini pun kita tahu garisan dia macam mana kan. So we have to do at least, kalau saya memang 3 is not acceptable lah. 3 tu hanya nak buat garis je. 3 paling pun 5 points of standard. Standards are prepared identically to the sample, have a similar composition or metric, and prepared in a range that is expected as the sample or the unknown sample. That is why another thing is you have to know the range juga. Kadang-kadang tiba-tiba your analysis tu, the sample dia tinggi sangat atas ni, so dia akan jatuh dekat tempat yang awak tak ada letak sini. Okay? Tak ada dalam garisan ni. So awak kena buat interpolation pun tak cukup bagus. So you have to, kalau tengok yang macam ni, maksudnya you have to increase lagi lah concentration pergi sebelah sini lagi. Tambahkan lagi. That is one of the way. Few types of standard. Ada standard yang dah ditentukan lah. Primary standard, secondary standard. Nanti kita tengok ni next LU Okay, the last part. Lepas kita buat analysis, calibration semua, last part dah ada data kan. That is what comes next is the data analysis. Dah ada data, dia bagi awak the value. 0.3, 0.4, 0.5. What is that? So you need to analyze. Apa maksudnya? Increasing trend, decreasing trend. Kalau maksudnya daripada level sungai, daripada hilir pergi hulu tu, concentration dia increase ke decrease? So what is that indicate? So that is what is data analysis. It require using the raw data, and you need to analyze the raw data stoichiometrically of the reaction or instrumental factor to calculate the analyzed concentration. And you need to evaluate the results and estimate their reliability. Okay, kalau kita nak tahu dia reliable ke tidak, masuk pula bahagian calculation which involve the statistical analysis. Okay. And habis dah 9 step tadi kena ingat 9 semua tadi yang define the problem, method selection, sampling, preparation of laboratory sample, replicating, preparing sample for analysis, eliminating chemical separation which limit all the inferences, perform the measurement and do the calibration, and lastly to analyze the data that you have now. So dah ada data, kena analyze. Di situ kita akan buat discussion. Apa sebenarnya indicate kalau concentration tinggi di kawasan ini? Maksudnya kawasan ini ada berlaku pencemaran air, for example. So that's the important of data analysis. Habis pasal step, and we look a little bit on quality assurance ni nanti kita akan masuk next learning unit. Next week. So next we look dekat common analytical problems. Ini beberapa contoh analytical problem yang ada lah. For example, in the characterization analysis, characterization maksudnya kita kena bagi sifat kepada benda yang kita analisis tu, kena describe. For example, determination of chemical structure. Kita satu benda dibagi, this is the sample, you need to give me the chemical structure of the sample. Panjang cerita ni, kena betul-betul determine. Using the FTIR, NMR even, kalau ada X-ray dia, you can go the X-ray analysis, then we can give the chemical structure. Okay, in characterization analysis, it involves the development of new methods, okay, for characterizing the physical and chemical properties. Okay, kita pun boleh bagi in terms of the particle size, surface structure, surface punya roughness dia macam mana, okay. And if the fundamental analysis, it will give you the idea on improving your understanding in the theory behind an analytical method. Okay, for example, extending and improving the theory on which an analytical method is based. Studying an analytical method's limitation and designing and modifying existing analytical method. Ini contoh kalau dari segi tadi kita analisis ni dia ada dua problem masalah. Dia pertama, awak nak analisis directly tadi guna method yang dah ada. Maksudnya contohnya kita guna AAS tadi kan untuk kita tahu concentration of nickel in water for example. Ataupun awak nak improve in term of fundamental, in which awak nak develop new lagi method untuk detect nickel. Selain daripada awak nak guna AAS, awak katakan, oh okay, saya dah develop satu method which is IoT, Internet of Things methods, in which awak selam saja saya punya sensor ni dekat dalam air, then dekat handphone awak apps tu, digitalization kan sekarang semua handphone kan. So awak selam saja reaktor ataupun detector tu ada dekat handphone, dia selam je handphone ni, tahan air. Selam saja handphone. So angkat balik handphone tu, dia dah boleh detect dah. Concentration nickel is around 0.1 ppm. Macam tu. So that is fundamental analysis where you develop pula new method in analyzing a problem. Okay. So ini contoh beberapa report previous report yang buat pasal analisis lah. But then kalau awak cari kat Google, tapi kan Google Wikipedia directly ambil je tu. From Google, ada Google Scholar tu kan. Google Scholar tu awak boleh type for example concentration, determining the concentration of apa-apalah. Ni saya bagi contoh yang lebih kepada water treatment lah sebab saya punya bidang water treatment. So, saya lebih banyak bagi contoh yang bahagian water treatment lah. So, contohlah kalau saya nak tahu the concentration of heavy metal in Sungai Sarawak. Kalau ada orang buat lah. Kalau tak ada orang buat, maybe awak nanti buat untuk FYP awak dulu ya. So, we give you the reports, all kind of articles. Okay, articles ataupun journal yang ada report tentang concentration. Yang ini pula contoh simple. Jadi nanti saya akan masukkan the paper in the e-lib lah. For example, dia buat contoh, adakah is bottled water safe? Air yang awak minum dalam botol tu selamat. So ini study yang dibuat oleh Professor Sherry Mason from State University of New York. Okay, dia gunakan beberapa jenis major brand lah. Contoh je lah, ini Evian kan. Yang guna botol, then daripada study dia, from this study, it indicates that air yang kita minum tu ada particles, contain tiny particles of plastic. Ada type of, contohnya kalau kita cakap pasal polypropylene, yang penutup ni bagi contribute about 54% of plastics in water yang kita minum tu. Bahaya juga kita minum plastik sekali rupanya kita ni selama ni kan. Lepas tu nylon 60%, polystyrene 11%, polyethylene PE 10%, polyester, polyethylene terephthalate 6% and others include azulon, polyacrylates and copolymers ada 3%. Bayangkan selama ni kita syok je minum kan, rupanya kita terminum dengan plastik sekali dekat dalam air tu. So this is one of this example of study yang melibatkan analytical chemistry. Okay, I think that is all on this learning unit. So macam saya cakap tadi, you need to, what is the most important of this learning unit is this step lah. Okay, yang lain ni, you can get the example of the chemical analysis, dah tahu apa beza qualitative and quantitative, and the scope application of chemical analysis. Kalau biasanya kita kena tahulah apa guna chemical analysis ni, bidang mana yang guna. Okay, contohnya dalam bidang apa. So, you need to find also what is analytical chemistry definition. And ini yang kita belajar tadi at the end of this learning unit. Okay, apa yang awak dapat sepatutnya? Okay, awak kena tahu what is the definition of analytical chemistry, what is the scope of the application of the chemical analysis, and you need to distinguish between quantitative analysis and qualitative analysis together with their examples, and you need to know how to extend the steps in chemical analysis and understand some common analytical problems. So yang nanti quality assurance unit of concentration and also basic statistic measurement kita akan cover dalam next week. Boleh? Rasanya sampai sini saja kot kita punya lecture. Ni pun dah pukul 10.30. Saya rasa ada yang dah lapar ni. Saya yang lapar So any question?
Madam, just nak confirm pasal lecture ni ada recording tak?
Saya dah record
Dengan tanya pasal record.
Saya dah record.
So macam mana kita orang nak access record tu?
Jadi kita akan linkkan dengan kita punya YouTube. Benda ni kita akan masukkan dalam YouTube tau. Sebab kalau masuk Elite terus, dia berat. Dia tak boleh buka. So usually we will start, we will upload it through Elite. Upload dekat situ link dia. Klik link dia lah.
Alright, thank you.
Sama juga kalau in case saya ada buat masa ni saya plan semuanya asynchronous. Semuanya synchronize online. Face to face macam ni, bukan face to face tak online, real time macam ni. But then in case kalau ada yang cakap it's kind of data consuming ke apa kan. So maybe I will do it in alternate ways lah. Maksudnya minggu ni macam ni, minggu ni macam ni, ataupun LU2 ni nanti semua dia guna video je. Tak ada macam ni, tak ada online macam ni lah. So kita tengoklah macam ni keadaan. So kalau recorded video tu nanti pun kita akan guna cara link kepada Elite tu lah. Boleh? Any question? Tak ada? Kalau tak ada soalan, maybe we can end our class today. Boleh? Kalau tak ada soalan, okay. Saya rasa macam tak ada je yang raise hand ataupun buat dekat chat box ni, semua tak ada. Lecture note will be given after this. Lepas tu tutorial biasanya kita nak bagi awal lagi lah. Awal-awal ni belum ada lagi. Biasanya we will cover tutorial at the end of the learning unit. Yang lain-lain tu ikut je schedule dia yang saya dah bagi tadi. Okay. If there's no any question, then we will call it a day. Rasanya 7 kot sampai hari ni. 7 kot kita punya lecture hari ni. So kita akan jumpa minggu depan. InsyaAllah. That's all from me. If you have any question or hesitation, you just can WhatsApp me. I've give you the number tadi kan. So apa-apa nanti boleh tanyalah WhatsApp. Introduce yourself. Apa pun. Okay, that's all from me. Thank you very much all. Assalamualaikum.
Thank you, madam. Waalaikumsalam. Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.